All right, so we're going to take a look at the notes for the first section, 7.1 to 7.2. And today we're going to go through problems. A lot of the material in here is prerequisite stuff. But again, I want to go through examples, talk through some of the key ideas of it. So this first example we have in 2007, the Boston Red Sox baseball team won 96 games out of 162 games played. It says write a ratio for the number of games won, all right, to the total number of games. All right, so we're looking at a ratio of 1 to total, all right, which in this case is going to be 96 over 162. All right, now ratios we can always reduce. All right, so what I noticed right away is both of these are divisible by 3, by 2, so we have 48 over 81. All right, both of those are divisible by 3 again, so we've got 16 and 27. And at that point, that's completely reduced because there's no common factors. Now, there's several ways we can write ratios. We can write it as a fraction, 16 to 27. All right, we can write it with a colon in between, so 16 to 27. All right, or we can just write it out in words, 16 to 27. All of those are equivalent ways to write it. The one that we're going to find the most useful in this class is writing it as a reduced fraction. All right, that's going to be the most beneficial in the problems where we actually use it. Now, sometimes a ratio will get extended, meaning that there's more than just two things being compared. All right, example 2 is a typical problem where they've extended the ratio from comparing 2 things to comparing 3. All right, so this says the ratio, excuse me, this says the ratio of the measures of an angle in triangle DOG are 2 to 3 to 5. And it asks you to find the measure of the angles. So if we go ahead and draw a picture here, we've got DOG. All right, so we'll just draw ourselves a triangle. And when it's 2 to 3 to 5, that really means that, like, whatever the angles are, the first angle is going to be a multiple of 2 of some number x. The second angle is going to be a multiple of 3. And then the third angle is going to be a multiple of 5. But they're going to share that common x value on each of them. So, for example, it could be 2, 3, and 5, which wouldn't work for a triangle, obviously. It could be 4, 6, and 10, all right? But it has to follow that ratio. So you could reduce an x out of each term and still get back to that 2, 3, and 5. So what we're going to do in the picture is we're going to go ahead and put these on. So it's 2x, 3x, and 5x. Now, we know from first semester that if I add up all those angles, 2x plus 3x plus 5x, that has to equal 180 degrees. So I've got 10x equals 180. I'll divide both sides by 10, and that will take me to x equals 18. All right, so when I look at this, I know the x value is 18. Now, this didn't ask me for the x, it asked me for the angle. All right, so when I look at this, 2 times 18 is 36. All right, 3 times 18 would be 30 plus 24, or 54. And then 5 times 18 would be 90. All right, and these are the 3 angles for this triangle. So we'll go ahead and label that answer. All right, now, a lot of times these will get used in a proportion setting rather than just using the ratio like we did on the last 2 problems. So in example 3, it says Mayor Joseph Fitzgerald O'Malley Fitzpatrick O'Donnell, the Edge, Diamond Joe Quimby, Jr., of course, conducted a random survey of 200 Springfield voters and found that 125 approved of the job he is doing. If there are 42,000 voters in Mayor Quimby's town, predict the total number of voters who approve of the job he is doing. All right, so first thing, we're going to take a look at the survey. So the survey was of 200 people and 125 approved. So we can say that the ratio is 125 out of 200. And that's approved compared to total. All right, so approved compared to total. So when I set up a proportion, all right, that proportion has to be in the same order as on each side. So if this is in favor or approving to total, the other side has to be approving to total. All right, we don't know how many approve, that's the question, so we're going to put an X there. But we do know that the total is 42,000. All right, and this gets me to a place where now I have an equation that I can solve. All right, so if I'm running through, first thing I'm going to do, in middle school we usually teach cross multiply, or you can just solve the equation, which is multiply both sides by 42,000 here. All right, but if I do it the way most of us originally see it, 125 times 42,000 equals 200 times x. All right, so at this, I'm going to need to likely grab a calculator here. We're going to divide both sides by 200. All right, and if we take a look on a calculator, let me get one here. We've got all right, so I've got 125 times 42,000. All right, that gives me 5,250,000, and I divide that by 200, and I get 26,250 for x. All right, so what we can say is based on this sample, we'd anticipate 26,250 voters approve of Mayor Quimby's job. All right, so they approve of the job he's doing. So that is 26,250 out of the 42,000. All right, and again, we're using the ratio from the sample that we took to draw a conclusion about the whole. All right, so this is only an estimate. It's not going to be perfect, but it is one way that they do estimates. All right, and then the last example on this group of problems says to solve this proportion. So we're going to go back to that cross multiply idea. So we're going to look at the first cross here. We're going to multiply those two together. 3 times 3x plus 1 equals, then we're going to go to the next cross and we're going to multiply those together. And that's 4 times 2x plus 5. All right, if I distribute at this point, I get 9x plus 3 equals, distribute over here, I get an 8x plus 20. All right, clean that up, I'll subtract 8x from both sides. I'll also subtract a 3 from both sides. So I get x equals 17. All right, and that would be my solution based on this original proportion. All right, and the method again is cross multiply. Keep in mind when we say cross multiply, it's a shortcut name we use, but in reality, it's no different than saying I'm going to multiply both sides of the equation by 4, and we get 3x plus 1 on this side equals 4 times 2x plus 5 over 3, and then saying I'm going to multiply both sides of this by 3. So I get to 3 times 3x plus 1 equals 4 times 2x plus 5. All right, notice that that's the same place we got going with the cross multiply idea. It's just another name for a process we've used before. All right, so I'll be back with the second part of this notes, moving into 7.2, but that gives you a quick overview of 7.1, which is ratios and proportions. Thanks.